you remember, this was the chart that we used to factor polynomials out. And the first thing that you always want to look for in factoring is to factor out a common monomial factor. After you factor out the common monomial factor, you want to decide if you have a four-nomial, which is 4 terms. If you have a four-nomial, you want to factor by grouping. If you have a trinomial, we worked on, if it was a perfect trinomial square, he factored into 2 identical binomials. Or we factored by trial and error, where we made a little factor tree and we determined what factors we needed in order to make that into 2 binomials we could factor into. If we had a binomial, we looked to see if it was a difference of 2 squares. If it was a difference of 2 squares, it factored into a plus b times a minus b. But the one thing that we haven't covered today is the sum or difference of 2 cubes. So if we have a binomial and it's a perfect cube plus a perfect cube, or a perfect cube minus a perfect cube, we can factor those out. And that's the last thing that we have on our note sheet, is the sum or difference of 2 cubes. Now in section 10.8, we're going to factor cubic polynomials. The first thing you always want to look for is a common monomial factor. So always start by factoring out a common monomial factor. That's your first step no matter what. On this problem here, notice it's a binomial. What do these 2 terms have in common that we can factor out? An x and an 8. They both have an x and an 8. So we take out the 8x. Remember, when we factor out the 8x, what we're doing is we're dividing each term by the 8x. What is 8x cubed divided by 8x? X squared. And what's 32x divided by 8x? -4. After we took out this common monomial factor, we have a binomial that's left. And if it's a binomial, you're looking to see 2 things. One, is it a difference of 2 squares? Or 2, is it a sum or difference of cubes? Which one is this? A difference of 2 squares. And the difference of 2 squares will factor into 2 binomials. What's the square root of x squared? X. Square root of 4? So it'd be x plus 2, and the other binomial is x minus 2. So remember, the difference of 2 squares, your binomials have to have different signs in the middle, because we need our middle terms to go to 0. Next example. We have a binomial here. First thing you always look for is to factor out a common monomial factor. What do these 2 have in common? 2y. We factor out a 2y, which means when you're factoring, you're dividing each term by that 2y. Oh, we better take out a 2y squared. Good job, Khadijah. Yes, because they both have a y to the 2nd power in common. So we should take out the highest degree that they have in common. If we take out a 2y squared, what do we have? 2y. And on the second term, if we divide by 2y squared, what is left? -5. Now this binomial, is it a sum or a difference? Or let me back that up. Is this a sum or a difference of 2 cubes? Is this a perfect cube? Is that a perfect cube? No. Is it a difference of 2 squares? No. So that's factored completely. Third example, we want to first start by factoring out a common monomial factor. What do these three guys all have in common that we factor out? 5x. We factor out a 5x. When we divide this first term by 5x, what do we have left? X squared. The next one we have minus 5x. And the third term, when we divide by 5x, what's left? Minus 6. Now in the parentheses we have a trinomial. If we go back to the previous slide, if we have a trinomial, there are two things you want to look for. One, is it a perfect trinomial square? Is this last term a perfect square? 6 is a perfect square? No, 6 is not a perfect square. The second thing that we want to do is look to factor by trial and error. By trial and error, that's the long method of factoring. So take your first term, which is 1, or the coefficient in front of the first term is 1, multiply by the last term, which is 6. What's 1 times 6? 6. What are the factors of 6 that have a difference of 5? A difference of 5. 1 and 6. Which one has to be the negative? 6. So we're going to go 5x. I'll put a bracket here because I'm going to have a lot of stuff in the parenthesis. I'm going to go x squared. If you remember, I always like to write the negative term first. Plus 1x minus 6. Now I factor by grouping. Any questions so far? What do these first two terms have in common? X. We factor out of x, and what do we have left? X minus 6. Good. And the next two terms, what do they have in common? So if we say nothing, what does that really mean? A 1. So we take out a plus 1, and we have x minus 6 in common. So we have our 5x out front. They both have an x minus 6 in common, and what goes in the other set of parentheses? X plus 1. So in this problem, we had to factor out the common monomial factor, and then we had a trinomial. A trinomial, we're either looking to factor by a perfect trinomial square or by trial and error, which we did our trial and error method here. Any questions? Moving on. What do we need to look for first? A common factor. What goes into these three terms evenly? 3x. We factor out a 3x. If I divide everything by 3x, what do I have left? 2x squared, 7x, plus 3. Now it's a trinomial. For a trinomial, I'm either going to see if it's a perfect trinomial square. Is the first a perfect square? Is 2 a perfect square? No. 3 is not a perfect square either. So it's not a perfect trinomial square. So now we'll try to factor by trial and error. What's the first multiplied by the last? 6. So what are the factors of 6 that have a sum of 7? 1 and 6. They both have to be positive. So we have our 3x. I'll do a bracket because I'm going to put a lot of stuff in here. We'll have 2x squared plus 1x plus 6x plus 3. What do these first two terms have in common that we factor out? X. If we factor out of x, what do we have left? These second two terms, what do they have in common? A 3. So if we factor out a 3, factoring out of 3 means we're dividing each of them by 3. So what do we have left? 2x plus 1. So from our common monomial factor, we have a 3x. They both have the quantity 2x plus 1 in common. And what goes in our other binomial? X plus 3. What's outside those factors? And now we factored him completely. Last week, Kaya, we looked to see already if they had a common monomial factor, and we factored those out. After you factor out the common monomial factor, look to see if it's a trinomial, factor by trial and error, or by perfect trinomial square, or if it's a binomial, is it a difference of 2 squares? One more example on this part. What do these guys have in common? X. We factor out an x. What do we have left after we divide each of them by x? X squared plus 4x plus 4. This trinomial is a special trinomial. Is the first a perfect square? Is the last a perfect square? Is the middle twice the product of their roots? So that's a perfect trinomial square, which will factor into 2 identical binomials. What's the square? So x plus 2, x plus 2. Remember, you have to take the square root of that number. So if that number is 4, the square root of 4 is 2. The binomials have to be identical.